Another way of solving differential equation is to the use of substitution suggested by the equation. Now, to use this one, basically, your MDX and NDY must contain common terms. So for example, this one, if you have noticed this x plus 2y as your MDX, as part of your MDX, is also located in your NDY, which is x plus 2y. X plus 2y and x plus 2y. Therefore, this method can now be used for this particular problem. Okay, so when we apply this substitution suggested by the equation, basically we will make use of substitution method. Okay, so again, this is the common terms for MDX and NDY. So to solve this problem, basically we apply a substitution method. So we will make use of another variable. So let's say let v equals these common terms x plus 2y, x plus 2y, so that the derivative of v is equivalent to dx plus 2 dy, and then dx here equals, we have here dv is equivalent to, dv minus 2 dy is equivalent to dx. Okay, so we will make use of substitution for this problem. So when we write our substitution, instead of writing x plus 2y, we will make use of v. So we have here v minus 1. And then in terms of dx, we will make use of dv minus 2 dy. So we have dv minus 2 dy. So that is your dx. And then we have here plus 3 times x plus 2y equals v. And then dy is equivalent to 0. Now, this time, we will multiply v minus 1 dv. So that is v minus 1 dv. And then b minus 1 times negative 2. So v times negative 2, that is equivalent to negative 2v. And then negative 1 times 2, that is positive 2. Of course, this is dy. No, so I will just continue here because they are both dy. So I will just continue plus 3v. So we have, I will write here plus negative. Okay, dy. So I'll just combine the result of b minus 1 times negative 2 dy and then 3v dy. So this is now the result, which is equivalent to 0. And then we have here negative 2b plus 3v, that is v plus 2. So we have v minus 1 dy and then plus v plus 2 dy. Sorry, this one is dv. Okay, dv and then dv. So we have dy, which is equivalent to 0. Now, by simple separation of variable, so if you have noticed, we can do the separation of variable for this part. We have v minus 1 over v plus 2 dv, which is plus dy is equivalent to 0. Now for this part, of course, we will divide b minus 1 over b plus 2. So I will write here b plus 2. So for this case, we will divide b minus 1 divided by v plus 2. So that v divided by v, that is 1. 1 times b equals b. 1 times 2 equals positive 2. And then we will subtract this one. B minus v, that is 0, negative 1 minus 2, that is negative we have v minus 1 minus 2, that is negative 3. So that our answer here is, instead of writing v minus 1 over v plus 2, we have here your 1 and then minus 3 over v plus 2. That is our dv plus dy, which is equivalent to 0. This time we will apply integration. Okay. Now if we integrate this one, that is equivalent to integral of 1 dv, that is v, minus, this one is v du over u, so we have here 3 ln of v plus 2 if we integrate this one. And then plus the integral of dy is equal to y. Okay, so integral of y, which is equivalent to c. We make use of c. Now this time, because we have already our answer here, instead of writing v, we will go back to x plus 2y. Okay, so x plus 2y. So instead of writing v, we have here x plus 2y minus, okay, this 3, I will make this 3 as your exponent to v plus 2. Okay, so we have your ln. Instead of writing v, we have your x plus 2y, x plus 2y plus 2. Okay, v equals x plus 2y and then plus 2 raised to 3, which is equivalent to c. Okay, and then, okay, that is now our final answer. So x plus 2, we have still here 3, sorry, I mislooks, plus y equals c. So the 2y plus y, that is 3y. So our final answer, we will write our final answer here. We have x plus, instead of 2y plus y, we will make use of 3y. 3y minus ln of x plus 2y plus 2, which is raised to 3, okay, equals c. Okay, so don't forget to subscribe my channel at Tom TV. Don't forget to click subscribe. Okay, so this is now our final answer for this particular problem. Okay, so that is plus C as our final answer. X plus 3y minus ln of x plus 2y plus 2 raised to 3 equals C. Another example for a substitution suggested by the equation is this equation, 1 plus 3x sine y dx minus x squared cosine y dy. Now, this problem belongs to substitution suggested by the equation. Now, before we start, don't forget to subscribe to my channel, Tom TV. You'll be notified to this example, or every recordings, you'll be notified. Okay, so back to this one. We have 1 plus 3x sine y dx, and then x squared cosine y dy. Now notice we have here your sine y, and then we also have cosine y. So take note, let's sine y is equivalent to, we will make use of other variable, let's say w. Okay, again, in a substitution, you can use any of the variable that you want to use. So for this example, I will be using w as my variable for substitution, so that let sine y equals w, then the derivative of w equals derivative of sine, that is cosine y dy, which is equivalent to dw. Okay, so I will rewrite this one again. We have here dw as my derivative of w. So this time I will substitute. We have 1 plus 3x. Instead of sine y, we will make use of w. So we have 1 plus 3x. Okay. Sine, instead of sine y, we have w. So 1 plus 3x w and then dx. So we have dx. And then minus x squared. We have here x squared. And then cosine y dy, this is cosine y dy, is in terms of dw. We have here dw, which is equivalent to 0. Now, if you have noticed, we have x squared dw and then 1 plus 3xw dx. This is in our previous discussion. This involves integrating factor. This is linear in W. If you have noticed, linear in W, we have here W dW. So we can write here linear in W. Okay. So if this is linear in W, then we can arrange this one in terms of dW over dx. Okay, so dw over dx, and then this one transfer to the other side, that becomes 1 plus 3x w all over x squared minus dw over dx is equivalent to 0. So for this case, this is dw, this dx will be transferred to dw. So it will become the denominator of your dw. And then this x squared will be transferred to this group. So it will become as your denominator for 1 plus 3xw. So we have this one. And then by rearranging this one, so we have 1 plus 1 over x squared plus 3x over x squared, so that is 3w over x minus dw over dx is equal to 0. And then by rearranging this one, I will transfer this one to the other side, that becomes positive, and then this one will become negative. Okay, so by rearranging or transposing this one, so if we transpose this one to the other side, that becomes 1 over x squared, which is equivalent to dw over dx minus 3 over x w. Okay, so this will be the setup. So I will write this one as dw over dx minus 3 over x w, that is equivalent to 1 over x squared. Okay, so this is what happened to this equation. So I will erase this one so I have enough space. Now, this we have here 3 over x. So we will have our integrating factor, that is the integral of 3 over x dx. This is p of x dx. So that when we integrate this 3 over x dx, that is equivalent to e raised to 3 ln of x, or that is equivalent to e ln of x raised to 3, or that is x raised to 3. That will be our integrating factor. So we will multiply by x cubed to both sides as our integrating factor. so that we can have x cubed times this one, that is x cubed, and then we have here dw over dx minus this one is 3x squared, 3x squared, and then w. And then the result here is x cubed times x cubed times x squared, 1 over x squared, that is equivalent to x. So that is the result. Okay, now this is x. By the way, we have a problem with negative 3 over x. We were not able to write negative 3 here, so we have here negative 3. Supposed to be this is negative 3, so that this one is negative 3, and then negative 3 as our exponent. So our multiplier now is x raised to negative 3. So this is negative 3, and then negative 3 x, this is negative 4. So this is negative 4. And then we have here negative 3 x raised to 2, that is negative 5. So for this case, if we raise this one, x squared, we have x negative 2, and then x negative 3, that is x negative 5. Okay, for this part. Okay, so I will again erase this one. So we have our integrating factor. Okay, I will erase this one. Now, after we have our integrating factor, once we multiply, then this one, if we combine this one, you have here, the result for this case is x negative 3. I will write here x negative 3, and then we have here w, which is equivalent to, of course, we will integrate this x negative 5 dx, x negative 5 dx. So when we integrate this one, of course, I will rewrite this part here. Okay, I will now erase this part. I will now erase. Okay. So x negative 3, and then we have here w, which is equivalent to integral, that is x negative 4 over negative 4. X negative 4 over negative 4 plus c. So we will try to multiply both sides by negative 4 because this is in fraction form. So if we try to multiply both sides by negative 4, as well as this x negative 3, x negative 4, this is also in fraction. So I will multiply by negative 4 x raised to positive 4. Why do I need to multiply both sides by x negative 4? Okay, this is x negative 4, this is x negative 3. So this is negative 4. So I will write here x to the fourth, because if I am going to rewrite this one as 1 over x cubed w, and then for this part, that is 1 over x to the fourth multiplied by x to the fourth. So we can cancel x to the fourth, and then this one we can also cancel here. So we are now deleting our denominator. So that's the main reason why I used to multiply both sides by negative 4 x negative 4. So we have, okay, if in another way, I will write it in a simplest form. We have w over x cubed equals 1 over negative 4 x to the fourth plus c. So I will multiply it by, this is negative 4x to the fourth. Negative 4. So again, we have here negative 4x to the fourth. So I will multiply by negative 4x to the fourth. So if we multiply negative 4x to the fourth by this group, what remains here is negative 4xw. Negative 4xw, which is equivalent to, we have here 1 minus 4c negative, 4c raised I times x raised to 4. So we have now got our final answer in terms of whole number, not in fraction. By the way, we have let sign y equals w. So instead of writing w, okay. Instead of writing w, we go back to sine y. So our final answer is 4x sine y equals 1 minus 4c x to the fourth. This is our final answer.